Bismillahirrahmanirrahim. This is yet another video on application of Laplace transform, and in this video primarily we'll be solving learning assessment 14.1 from the book Basic Electrical Engineering, Basic Electric Circuit Analysis. Let's just revise the steps that are recommended to follow. First is we transform the circuit from time domain to S domain or Laplace domain. Then we solve the circuit using any of the analysis techniques that we have learned. And then we take inverse Laplace to go into the time domain. Okay, now this is the question. We have to find IOT for the circuit. IOT is the current through this branch using node equations. So let's proceed. As we mentioned, we have to first convert it into S domain. And to convert into S domain, we first of all, let's say, take the capacitor. We know the capacitor in S domain is written as 1 over SC when the initial condition is 0. And C is 1 farad here, so we put 1 here, then it will become 1 over S. So we'll replace this by 1 over S. Similarly, this source to UT can be written as 2 over S because UT is written as 1 over S in S domain. And similarly, 12 UT will become 12 over S. And the inductor is represented by SL. Here L is 1, therefore SL will become S. So let's now draw the S domain circuit by plugging in these values. You can see we have changed the values, all of these. Okay, now if you look carefully with this circuit, you may recall that this is a nodal analysis circuit, but this voltage source is in between the two nodes. Therefore, this forms a supernode. So this is a supernode, and if you don't recall how to solve supernode problems, then I would strongly recommend that you watch my videos on supernode. Okay, so this is the circuit, and we have now added a couple of things like the currents in these branches. Only this current was given, but I have named it now I2. This current I have named I1, this current I3, and this was given I0. Also, we have written the two node voltages V1 and V2. And I hope you recall that this is considered as one node as far as the KCL is concerned. So we'll write the current entering equals current leaving by KCL. Now this is current entering, I2 is entering, and all three are leaving. So I2 is equal to I1 plus I3 plus I0. And now we write these currents in terms of voltages. Okay, now since this is a current source, we'll write it as it is. So 2 by S. I1 is this current, and coming from V1 to ground, this ground is here. So we'll write it V1 minus 0 divided by this, but we generally don't write 0. So it is V1 divided by 1 over S. Similarly, I3 is V2 divided by S here, and this one is V2 divided by 2. And now we'll try to rearrange these terms. I hope you can do it. This goes up and taking common terms. So this is the final equation in terms of V1, V2 and the constant. Okay, I hope you also recall that for supernode we have to write a KVL equation as well. So let's write the KVL equation. KVL equation is written around this loop. So this is V1, this means negative is here, positive here, so we'll write negative V1, so negative V1, then this source positive, so positive 12s, and then positive of V2, so V2 equals 0. And from here, we can find V1 to be V2 plus 12 over S. So this is our second equation. Now since we are interested in V2, therefore we'll try to solve it for V2. So we'll plug in or eliminate V1 from this equation by putting in this value of V2. So we'll put the value of V1. So now all we have is V2 terms left, and we will now solve this circuit to find V2. So steps, I hope you can follow. I have done all the steps, but I'll not go on explaining every step because that will take a lot of time. But if you have difficulty, just pause the video and try to figure out. So this, from here, we take this term and these two, and the constant terms 12 multiplied by S becomes 12 in this. And again, now taking LCM. Okay, so we were here, and from here we just keep V2 on this side, other terms goes on the other side, get divided or inverted. Further solving. Now, while we are solving for V2, we have to keep in mind the aim, what do we want to achieve, as we have these two formulas which may be applicable in this case, and this is S plus A square omega square, and same here, but the numerator is different. One has omega and other has S plus A, and we get the time domain, these two functions, EAT sin omega t and EAT cos omega t. So we should try to mold this in either of these forms. Okay. So for this, we take two common from here. So this becomes the remaining terms, and then we try to get into this form. So we S square, S by 2 can be written as 2 into S into 1 over 4. So this will cancel and make it equal to S by 2. And to make it whole square, we add 1 plus 4 square. 1 plus 4 square is 1 over 16. So from 1 over 16 gone, so left is 15 over 16. And so this term will make the whole square, S plus 1 by 4 whole square. And this can also be written in the form of square, so under root 15 over 4 whole square. And now that we have done with the denominator, let's try to play with the numerator now. So we take this term common, S minus 16. Now we'll try to bring the numerator in either omega form, which is under root 15 by 4, or S plus A form, that is S plus 1 by 4. So that is why we are now manipulating. 1 over 6 can be written as 4 over 24, and we will see in the next step why we are doing that. Okay, so 4 over 24 or minus 4 over 24 can be written as 6 over 24 plus sign minus 10 over 24. And from here we take this term separate, 10 24, 6 by 24 can be written as 1 over 4, and now you can see this has started matching with this. Okay, now we separate these two terms, so this becomes the one term, and this is the second term. Now if you look again here, now the first term has matched exactly with the cosine omega t form of transform. So S plus A, or S plus 1 over 4, S plus 1 over 4, and this is omega. So this we have achieved the goal. But the other term does not match with omega. We should get it under root 15 over 4, so it will match with the sine omega t terms. Okay, so let's further. So we were here. This now we have to achieve. Okay, so to achieve under root 15 over 4, we multiply by under root 15 over 4 and divide by 15 over 4. It will become 4 over 15. And now we'll separate this term. So we take this out, it will become 20 over under root 15. And now the numerator is omega. This is our omega square, so this is omega. So now we can apply this formula as well for the second term. So far we were in the S domain, and now we are now ready to go into the time domain. So we now write it as v to t 12, and for this we'll write this formula e raised to the power minus t by 4, because our a is 1 over 4, and cos under root 15 by 4 is omega t. Similarly, for the second term, this is the constant term, and then e raised to the power minus t by 4 and sine omega t, or sine under root 15 by 4t. So this is our time domain representation, but we are not done as yet. But although this is the answer, but in the book he has given a different form, so we'll try to adopt that form. Okay, what we have done here is we have solved this 5.16 to make it simple. Now we take e t by 4 common from both, so this is what is left. So we have to now play with this term. So we were here, and now we'll take help of this formula here. This formula, a cos omega t plus b sin omega t is equal to c cos omega t minus theta, where c is under root a square b square and theta is tan inverse b over a. And so by calculating, this is our a and this is b, so we find c to be 13.06. Now theta will be tan inverse of this. Now if you try to calculate it through a calculator, you will get an answer of minus 23.3 degrees, which is not correct. And let's see why it is not correct. Now if you see from this diagram, this is our x-axis and this is y-axis. X is 12 and y is 5.16. So the point lies somewhere here in the second coordinate, not in the fourth coordinate. So when it is showing minus 23, that means it's considering it to be in the fourth coordinate. So we have to manipulate, we have to add 180 degree with this to come into the second coordinate, and so our answer will be 156.07 degrees. And so now by this formula we can write ET we have taken out, so underneath this is now 13.6, that is c cos omega t and minus theta. So this is our answer, and this is for the voltage V2. Now if you look at this circuit, we have found this voltage, we need to find this current, so this will be the voltage divided by 2 ohms resistance. So current IOT will be voltage divided by 2 divided by 2, and so this is the final answer that we should get, and this is what we have in the book answer given. So I hope this gives you an idea how to solve this problem, although this is actually 2 problems in one. Thank you.